Patil from Department of Artificial Intelligence and Data Science. Today I will present a topic search space in game playing algorithm. So let's start. Objective for the topic is understanding the concept of search space, analyze type of game and search strategy. Study component of search space, compare search techniques, explore classical algorithm, learn heuristic and evaluation function, highlight application beyond games, identify challenges and future trends. The introduction. AI is used in a game to stimulate human-like decisions. The goal is to make the computers predict move, plan strategy, and adapt like human player. For example, chess. AI in release on search algorithm to evaluate all possible states. AI, game, algorithm, decision making. The cycle is continuously working. So let's know about what is a search space. A search space is a set of all possible states or a configuration on a problem. Each point in a space represents a unique state of a game. Search, search space has four, four main states: state, action, outcome, and goal. Exploring the search space helps the algorithm decide the best one. In game, the search space is usually very large. Importance of search space. Define the boundaries of decision making. Help the AI understand what options exist. Allow systematic evaluation and moves and outcome. Without search space exploration, AI can't be optimal. Input, explore, evaluate, decide, and goal is the main important step for search space. So let's know about representation. In game playing algorithm, the search space represents all possible states that can be reached from the initial position from the game. Root node. First is a root node. The root node represents the starting state of the game. For example, an empty chessboard for a starting configuration in tic-tac edges. Each, each edges indicate all possible move or transition from one state to another. Every move made by the player expands the search space further. Next is a child node. The node that result from making move from the parent node are called child node. Each child node represents a new game state that results from a specific action. Leaf node. This node represents terminal state where the game ends, such as win or lose. Search space. The entire structure forms all possible nodes and their connecting edges in search space. It defines all possible sequence of move from start to finish in game. So know about the concept of search space. Represents all possible configuration, each node equal to game state. Each node represents a game state. Each edges represent the path or the move or a action, depending upon a branches, factor and type. For example, chess. Component of search space. Four main components: state, action, transition model and goal. State means a current game position. Action means a possible move from one state, a state. Transition model define how state changes. Goal state, win or lose or draw. Type of search space. The main type of search space is firstly from starting type of search space. Let's differentiate the all state versus problem space. State space. The state represents a unique condition of snapshot of a system at any given point in a time and the state space is a collection of such all states. The state space represents all possible states a system or a game can read, including even irrelevant ones. Problem space. The problem space is focused part of the state space, only those states that help reach the goal. For example, in chess, every legal and illegal position from the state space, but only legal reachable position and make this problem space. Next is a continuous versus discrete search space. Discrete search space. A discrete search space consists of finite and countable number of states. Each state of contemplation is distinct and separate from the other. Meaning of the algorithm move from one specific state to another. It is the most common and combinational and game playing problem where actions and outcome are clearly defined. For example, tic-tac-toe, chess, puzzle, game root, and root finding in craft. Continuous search space. A continuous search space involves an infinite number of possible states. States are defined by continuous variable, often represented by a real number. A transition between a state can take any value within a range, rather than a moving step by step. For example, path planning for a route. Next, it is, is deterministic and statutory. Deterministic search space. Deterministic search space. The result of every action is predictable and fixed. There is no randomness performing the particular action in a given state always leads to the same next state. This environment allows the algorithm to plan the exact sequence of moves to reach the goal. For example, chess, checkers, tic-tac-toe, moves have fixed outcome. Next is a static search space. In this, action may lead to different outcome even when applied to the same state. The environment contains randomness or uncertainty, so result not completely predictable. Algorithm must take probabilities into account while making the decision. For example, weather forecasting. These are the example of search space: tic-tac-toe, small and deterministic; chess, large and predictable; Go, massive search space. Search strategies in game playing algorithm. It means affect performance and efficiency. Type of search space strategies. Uniform. Here are the main two types: unformed and informed. Unformed search strategy. It means it also known as a blind search strategy are algorithms that explore the search space without having any additional information about the goal's location other than the problem defi- definition itself. In uninformed search strategy, there are three types of search: breadth first search, it explore level by level; depth first search, explore deep first; uniform cost search, explore all costs. Next type is uninformed search strategy. It means use heuristic to guide exploration. Uninformed search strategy, also known as heuristic search strategy, make use of extra information or knowledge about the problem domain to find the solution more efficiently. It also contains three types: A-star search algorithm, greedy based first search algorithm, and hill climbing search. In A-star, most widely used in uninformed search algorithm. Greedy based first search, it consists faster but not always optimal. Hill climbing means uh, the path is be doing step by step. Next is a game tree representation. How we represent a tree in space. Let's know about it. The road, firstly, it is a root node. It is the initial state. Then it has branches equal to moves. Then it have leaves, means terminal state. Then it goes in depth, number of moves ahead. It means the how we represent a game or tree. It is we can conclude about. Next topic is the classical gaming algorithms. The classical gaming algorithms min max. It known about optimal play. Alpha beta pruning, faster minimax, expin max handle randomness. Min-max algorithm. The min-max algorithm is a decision-making algorithm used in a game playing like chess, tic-tac-toe, and checkers to find the optimal moves for the player, assuming that the opponent also plays optimal. It's working. Firstly, generate game tree. It creates all possible moves. Next is evaluated terminal state. Assign score, win or draw or lose. Backtrack. Max choose the highest value, min choose the lowest value. And lastly, select the best move. The root move with the best score is chosen as optimal moves. Next is beta pruning. Alpha beta pruning is an optimization technique used in a minimax algorithm to reduce the number of nodes available in the game tree. It eliminates branches that cannot influence the final decision, thus saving time and computational without affecting the result. Working. Working principle. The algorithm maintains two values during the search. Alpha, the best value that maximizer. Beta, the best value that the minimizer. During the traversal of game tree, if at any point beta is less than or equal to alpha, the remaining branches are pruned, means ignored because they will never affect the final outcome. Next is the Iptimax, handled randomness. Next is the Iptimax. The Iptimax algorithm is an extension of Minimax algorithm used when the game or environment involve randomness and uncertainty. It helps in decision making where outcome is not completely predictable. Working. Three type of node: max node, min node, and chance node. Max node mean player turns, min node mean opponent turns, and chance node mean represent randomly. Evaluation. Instead of always minimizing or maximizing, Optimax calculate expected utilities based on probabilities. Decision. The algorithm selects the move with the highest expected value. Next is the role of heuristic in search space. In AI, a heuristic is a method of rule of thumb that help a search algorithm make intelligent decision about which path is explored next. The role of heuristic to provide guidance during the search process and estimating how close a given state is the goal. Working of heuristic. Heuristic function h of n is used to estimate the cost or distance from the current state. The algorithm uses the function to decide which node to explore the next. A smaller heuristic value indicates that node is a closer to the goal. Best example is a maze solving problem. Next is a challenge in search space exploration. What challenge we faced during the search space exploration? First is the need for balance between accuracy and speed. High computational cost for large games. Real-time constraint must decide in a millisecond. Memory limitation. Dynamic opponents changes the strategies. Application for the search space. AI based chess and Go engine strategic game. For example, StarCraft Age of Empire, robot planning and decision making, self-learning AI agents, reinforcement learning simulator. Lastly, we conclude that a search space from the foundation of AI, gameplay, algorithm, minimax alpha beta pruning, efficiently explored, heuristic make intelligence decision and faster. The combination leads to smart, human-like gameplay. Thank you.